In this video, I'm planning on talking about oxidation reduction reactions. This is also called redox reactions. So redox reactions are oxidation reduction reactions. So what are oxidation reduction reactions? Well, basically oxidation reduction reaction just means that electrons move from one atom to another atom. So let's say that we have an atom here, so this is atom 1, and we have a second atom, so let's just call that atom 2. And if we have an electron that moves from atom 1 to atom 2, so let's say this is our electron, then this would be referred to as oxidation reduction. So what's happening here is that this atom 1, so this atom loses an electron, and the second atom, so atom 2, gains an electron. So this one gains an electron. So where does this oxidation reduction come in? Well, so when an atom loses an electron, this is called oxidation. And when an atom gains an electron, this is called reduction. And this might be a little bit confusing because why in the world is something that's gaining something referred to as being reduced or as a reduction? Well, the way that I think about this is since electrons have negative charge, so I'll just put this up here. So electrons have negative charge. So let's just think about this for a minute. So let's say that we have an atom that has let's just say we have magnesium. So magnesium can have a 2+ charge. Well, let's say that this magnesium gains 2 electrons. So if we add 2 electrons to this, magnesium, the charge on magnesium is going to be 0. So we've added 2 electrons to magnesium, and the charge that magnesium has been reduced. So as we add electrons, the charge goes down. So if we have something that has, say, a 3+ charge, if we add an electron, now it's a 2+ charge. So what we did is we, let's say, add an electron, and now it's a 2+ charge, and let's say that we add an electron, now it's a 1+ charge, and let's say that we add another electron, now it's a 0 charge, and then we can keep going. If we add another electron, now it's the 1- charge. So this is what I think of for why this is called reduction. And another way to remember this is there's a few mnemonics out there to remember that oxidation is losing electrons and reduction is gaining electrons. The one that I like is oil rig. So what this stands for is oxidation. So oxidation is loss of electrons. And so we have the oxidation is loss, and then you're talking about electrons. And then the rig part, we have reduction is gain of electrons. So we have the reduction is gain and then of electrons. So just if you remember oil rig, you'll be able to work out that oxidation is loss of electrons and reduction is gain of electrons. Or you can try and remember this, that it's called, when something gains an electron, it's called reduction because the charge is being reduced because when we add more electrons, that reduces the charge. Now let's look at some specific examples of when oxidation reduction occurs. So we've already seen this reaction where, let's say that we have sodium and we have chlorine, and these will they'll combine to form sodium chloride. So this is an example of an oxidation reduction reaction, and the reason why is because we have sodium that's going to lose an electron, and we have chlorine that's going to gain an electron, and then these are going to have opposite charges, so they're going to stick together. So these are going to form an ionic bond because they're sticking together. So we have, over here we have Na, and this has a plus charge, and this is sticking to chlorine, which has a negative charge. But what needs to happen before these can stick together? So these, when we're over here, on this side, so these are our reactants, this is our product. When we're over here, the sodium and chlorine don't have a charge. So the sodium and chlorine over here can't stick together. So what needs to happen is the sodium needs to lose an electron and the chlorine needs to gain an electron, so that then these will get a charge and then they can stick together. So what's going to happen, let's just draw the sodium and the chlorine. So these are our sodium and chlorine atoms. And what's going to happen is that sodium is going to give up an electron and that electron is going to go over to the chlorine, and we're going to end up with sodium with a positive charge because it lost an electron, and we're going to end up with chlorine with a negative charge because it gained an electron. So this looks like this, where we described, so the sodium is losing an electron, so it's being oxidized, and chlorine is gaining an electron, so it's being reduced. What we can do is we can actually write chemical equations we can write a chemical equation for each of these processes. So we can write a chemical equation for the oxidation step, and we can write a chemical equation for the reduction step. So if we write a chemical equation for the oxidation step, we get Na, this is just sodium, and actually let's start with the chlorine. So let's start with the one that's being reduced. So remember, with a chemical equation, we have the reactants on the left side and the product is on the right side. So with the chlorine, what's happening is we're adding an electron to chlorine. So we have chlorine, and then we have plus, and it's gaining an electron. So we're going to write chlorine plus an electron, and this is equal to chlorine, so the chlorine ion, so chlorine with a negative charge. Now this one is a little bit strange, because you would think that you would just, because sodium is losing an electron, so it would be tempting to write sodium minus an electron goes to Na plus, so sodium with the positive charge. But it turns out we can't actually put negative signs in these chemical equations. The signs between the reactants and the products always have to be positive. So the way we have to write this is we say that sodium becomes, and we're getting the sodium with a positive charge, so we have the sodium ion, plus, and we have an electron as the product. So when sodium loses an electron, the products that we get are sodium, the sodium ion, so sodium with a positive charge, and an electron. What we can do, so this is the oxidation, so this is showing this is the chemical equation for the oxidation of sodium, and this is the chemical equation for the reduction of chlorine. So these two equations are what are known as half reactions. So these are half reactions, and so the half reactions show the reaction, or the reaction for the oxidation step, and they show the reaction for the reduction step. And we can write these half reactions for any oxidation reduction reaction. And the other thing with oxidation reduction reactions is that oxidation and reduction always happen together. If something's being oxidized, something else is being reduced. You can't have these on their own. They're always going to be there's always going to be two half reactions. And so basically, if an electron is lost, another atom has to gain an electron. What we can do is, so these are the half reactions. These two half reactions can be combined into this net ionic equation that we have written here. So this equation up here is referred to as our net ionic equation, and the reason why is because this equation shows the total reaction, so it has the two half reactions combined. And the way that this is written is we take these two equations, so we take everything on the left side and put it on one side, so we have Na here, and then we have chlorine plus an electron here, so plus Cl plus an electron, and then we draw our arrow, and then we write everything that's on the right side, so all of our products. So we have Na plus we have an electron, plus over here we have chlorine with a negative charge. So these two electrons can cancel out because we have the same thing on both sides. And we know that when we have sodium and chlorine, the sodium and chlorine ions, they're going to stick together to form this NaCl. So they're going to form a salt. So then we can write this full net equation. So we can write the net equation as Na plus Cl, and then we have NaCl over here. And this is the net ionic equation. A quick question. Going back up to this equation, what if we started out with sodium with a positive charge and chlorine with a negative charge? So let's say that we were given this. So these are already, sodium and chlorine are already ions. Is this an oxidation reaction? Think about it for a minute. So if we have sodium with a positive charge already and chlorine with a negative charge already, and then we get sodium chloride, this is not an oxidation reduction reaction because this equation isn't showing any transfer of electrons. The electrons have already been transferred before this equation. So this equation is written assuming that the electron transfer has already happened. So this chemical equation isn't showing any electron transfer. So in order for an oxidation reduction reaction to happen, there has to be an electron transferred. So if there's no electron transferred in your reaction, then it's not an oxidation reduction reaction. So if we take these off, so then these are the sodium chlorine with the neutral charges, then this equation here is representing an oxidation reduction reaction. Okay, now I'm going to erase some of this and talk about another oxidation reduction reaction. So an oxidation reduction reaction that you've probably pretty familiar with, you just don't know it, are what happens in batteries. So we've all heard of batteries. batteries are what power our different electronic devices. They power our computer. We have a battery in our car. We use batteries for pretty much everything. And so a battery is what's referred to as a galvanic or voltaic cell. And what these are these are devices that use a chemical reaction to produce electricity. So all of these. So these use a chemical reaction to produce electricity. And this chemical reaction is an oxidation reduction reaction. Let's look at an example of a voltaic cell. So this is basically a battery, and this is one of the batteries that we made in the lab on batteries. So what we had was, if you remember, we had two containers of water. So these are two containers of water. And we dissolved zinc sulfate into one of these. So this one, let's say this one has zinc sulfate dissolved in it. And if this has, when we put zinc sulfate into the water, it's going to dissolve. So we're going to end up with zinc with a bunch of zinc ions, basically. So we're going to have a bunch of positive charges. And in this water, we put copper sulfate. So the copper sulfate dissolved in the water, and we had all these, we had copper 2+. So we had all these copper ions that have a positive 2+ charge. And then we put zinc solid metal into this side. So this is the zinc solid metal. And we put copper solid metal in this side. So this is the copper. And then what we did was we connected these together with a wire. And so we're going to talk about the details of this reaction in a minute. But what happened when we did this is electrons began to flow from this side over to this side. So electrons were flowing from the zinc to the copper. So we had electrons flowing through this wire. So I'm going to just put some electrons. And so the electrons are flowing through this wire, and they're going from the zinc to the copper. And this happened spontaneously. So when we connected these together, this electron flow just happened spontaneously. And so it turns out that moving electrons produce electricity. So when these electrons were moving through this wire, they were producing electricity. So if we, say, connected a light bulb to this wire, it would turn on. So we're producing electricity in this wire from the flow of electrons that are going from zinc to copper. What I want to do is erase this stuff, and I'm going to redraw this so that we can look at the details of what's happening. So what I want to do, so I've erased everything and I've redrawn this drawing of our battery. So what we want to do is look at what's happening here in detail. So let's start over here. So over here we have zinc sulfate that's dissolved in the water. So we have all these zinc ions, and we have a solid piece of zinc metal in this water. So this zinc metal has the zinc atoms are all stuck together, and so the atoms in this zinc metal don't have a charge. Like these are just zinc with no charge in the metal, and then we have the zinc ions in the water that came from the zinc sulfate. So when we mixed the zinc sulfate into the water, it dissolved, the zinc sulfate dissolved, and we got these zinc ions, and then we just stuck a piece of zinc metal into the water. So that's what this is. And then we come over here along this wire, and over here we have a solid piece of copper. So this has all of the copper atoms, and the atoms in this copper don't have a charge. And then we have all of these copper ions in the water. So we dissolved the copper sulfate into this water, and we got, so this dissolved, and we ended up with all of these copper ions with a 2+ charge. And then we've said that electrons will flow from here over to here. So why does that happen? Like, why are these electrons flowing from here to here? Well, the reason why is because copper has, or the zinc 2+, has a stronger pull for electrons than the zinc. So the zinc is pretty willing to just give away electrons, and the copper wants electrons. So this copper is going to be like, give me some electrons, and the zinc is like, okay, fine. So the electrons are going to go from the zinc to the copper. Let's look at exactly what's happening in here that's causing the electrons to go from the zinc to the copper. So over here we have this solid zinc, and let's just draw one of our zincs right here. Well, okay, so over here we have this solid zinc, and so we basically have, like looking at the zinc that's in this metal, we have zinc, and this zinc is going to lose 2 electrons. So our reaction is going to look like this. We're going to have zinc, and the zinc is going to lose 2 electrons, so we're going to end up with zinc with a 2+ charge plus 2 electrons. And so this zinc atom that's in the metal is losing 2 electrons. And then what's going to happen when this loses 2 electrons, the two electrons are going to flow along here, over here, and then over to this side. So what's going to happen when we have the zinc that's in the metal, and now it's an ion? So zinc, neutral zinc, so neutral metals are solids. So if we have a neutral metal, or sorry, if we have a neutral atom, this makes a solid metal. Metal ions usually dissolve in water. So what's going to happen is this neutral atom that's in the zinc metal loses 2 electrons, and so now it has so now it's an ion. Now it has a 2+ charge. So what's going to happen is it's going to dissolve in the water. So this atom is going to come out of the metal, and it's going to dissolve in the water. So we're going to add another zinc 2+ to the water. And then coming over here, so this electron is going to flow over to the copper, and it's going to flow through the copper and then come out here. And one of these copper ions, so we have the Cu 2+ ion, it's going to gain 2 electrons. So these 2 electrons are going to flow over here, and then they're going to combine or they're going to add themselves to this copper ion. And what we're going to get is a neutral copper, because the copper is going to, so going back to this rule here, neutral atoms make a solid metal. And so if we have a neutral atom in here, so one of these copper ions is reduced with 2 electrons, and it becomes a neutral atom. It's gonna end up falling out. So we're gonna end up with a solid metal, so solid copper that sticks to this copper that we already have here. Then these two equations should look familiar. Remember, we're talking about oxidation reduction reactions. So we have the zinc here. The zinc is losing electrons. So if something is losing electrons, it's being oxidized. So this is the oxidation process. And over here, the copper is gaining electrons. So this is being reduced. Remember, if something is gaining electrons, it's being reduced. So this is the reduction process over here. And I'm going to actually go back and write in what these different things are. So this zinc, remember, so we're starting out with a solid zinc here. So we're going to put an S in parentheses next to the zinc to represent that this zinc, when it's in the zinc metal, it's a solid. Once it becomes an ion, so let's move this over. So once it loses 2 electrons and it becomes ionized, it's going to dissolve in solution, because remember, metal ions usually dissolve in water. So we have an ion now once it loses the 2 electrons. So it's going to dissolve in the water, and now we're going to put this AQ, that stands for aqueous. So aqueous means that it's dissolved in water. And then coming over here, I'm going to move this over. So we have this copper ion that is dissolved in the water. So we're going to put aqueous on the copper. But then once this copper ion gains 2 electrons, it's going to have a neutral charge. So now it's going to form a solid, because a neutral atom makes a solid metal, and metal ions usually dissolve in water. So this copper ion, once it gains 2 electrons and becomes neutral, it's going to solidify in the water. So basically it's going to solidify to this piece of copper. So you can imagine that what's going to happen during this oxidation and reduction process in this battery is this piece of zinc is actually going to get smaller over time. So you're going to see this shrink, because you're losing atoms from it, and this piece of copper is going to get bigger. So you're going to see this get bigger and expand out. So when we're talking about this sort of oxidation reduction reaction, these are referred to as half cells. So this one is the oxidation process. So this side is referred to as the oxidation half cell. And this side is where the reduction process is happening. So this is referred to as the reduction half cell. And each of these reactions, so these 2 reactions that we wrote here, so this is the reaction for the zinc losing electrons and becoming an ion, and this is the reaction for the copper gaining electrons and becoming a neutral atom. These are referred to as half reactions. So what we can do is we can take these 2 half reactions and we can write the net ionic equation. So the net ionic equation, and Remember, for the net ionic equation, we basically just combine these two equations. And the way we're going to do that is we're going to take everything on the left side and combine it on the left side up here. And we're going to take everything on the right side and combine it on the right side up here. So to do that, for this first half reaction for the oxidation process, we have zinc, and that's the only thing on this side of this equation. So let's go to this half equation. Or this half reaction. So we have everything that's on this side. So we have plus copper plus the 2 electrons. And then this becomes, and now we write everything that's on the right side. So we have zinc, the zinc ion. So zinc 2 plus, and this is aqueous. Plus we have those 2 electrons, plus we have solid copper. And then what we can do is cancel out so we have these 2 electrons on both sides, so we can just cancel those out. And then we can write the full net ionic equation. So we have zinc plus copper ion, and this becomes the zinc ion plus copper. So what I'm going to do is erase some of this, and then I'm going to show you how to write these equations in what's known as cell notation. Okay, so this right here is our net ionic equation, and we got this by combining these 2 half reactions. So these are the half reactions, and when they're in this galvanic or voltaic cell, they're referred to as half cells. So this is the side that the oxidation takes place, that's the oxidation half cell, and the side that the reduction takes place, that's the reduction half cell. And these can be written in a shorthand notation known as cell notation. So I'm just going to show you another way that we can represent the same information using a different notation. So what we do is we start with the oxidation process. So we're over here, and we have the zinc is being oxidized to the zinc ions. So we write zinc, and it's a solid, and then we put a line, and then we write the zinc ions. So we have zinc 2 plus, and this is aqueous. Now we're going to go over to the reduction half cell, and we're going to draw 2 lines to separate the oxidation half cell from the reduction half cell. And then we're going to write the copper ion and the copper the same way we did the zinc for this reduction process. So we have the copper ion, and it's aqueous, and then we draw a line to separate, just to represent that the copper is gaining 2 electrons to become neutral copper. So now we have copper solid here. So this is just another way to write this information, so that this is a shorter way to write this information. So just as a summary, we've been talking about oxidation reduction reactions. And remember, oxidation reduction reactions are when you're moving electrons from one atom to another. So, and remember that oxidation is the loss of electrons, and reduction is the gain of electrons. So, and these can't happen by themselves. So if something is being oxidized, something else is being reduced. We started looking at this formation of salt. So we had NaCl, and we got NaCl. So just to remind you, this was a redox reaction because the sodium is losing an electron, the chlorine is gaining an electron, they're becoming ionized, and then they stick together because they have opposite charges. But the reason why this is a redox reaction is because an electron transfer took place. An electron was transferred from the sodium to the chlorine. And then going to this reaction that we're looking at in this voltaic or galvanic cell or battery, the zinc is losing electrons and the copper is gaining electrons. And so this is a redox reaction because zinc is losing electrons, so it's becoming oxidized, and the copper is gaining electrons, so it's becoming reduced. I hope this video was helpful. Thanks for watching.